So welcome everyone. Thank you for joining us for the Corn Earworm Integrated Pest Management Updates for Sweet Corn webinar. This webinar is being hosted by the Northeastern IPM Center, and it's covering updates from the Corn Earworm IPM project team. So a few things before we get started, I just want to give you some information about. If you look in the bottom of your Zoom there, you will see the CC for captioning. So we do have live captioning. If you would like that feature turned on, you can see a transcript of the webinar as it's happening. We will also be recording this webinar. The recording will be sent out to all the registered attendees, and it will also be posted on our website at cornearwormipm.org. In terms of questions, we will be having a question and answer session at the end of the two presentations. So we'll be holding the question and answers for both presentations at the same time. We do appreciate, since we have a lot of registered attendees, you using the question and answer feature. So again, at the bottom of your Zoom controls, you should see a Q&A. That's where we would like you to insert your questions. And then if you'd like to ask your questions anonymously, just say that right at the beginning of your question, and we will address those questions and kind of group them together around themes to ask the panelists. So I'll go ahead and get started with introductions. I'm Kelly Hamby. I'm an associate professor at the University of Maryland in the Department of Entomology. I'm also the project director for the regional team that's working on corn earworm integrated pest management in sweet corn. And of course, as I mentioned, we do have the website, cornearwormipm.org, and I will go ahead and drop that link in the chat in just a moment. Today, I'm really happy to introduce our speakers for the two presentations that we will be doing. First, we have Dr. John Nahas. He's going to be presenting first, and he is a postdoctoral research associate with Dr. Brian Nault at Cornell Agritech. It's a vegetable entomology lab. He earned his bachelor's in biology from the College of Coastal Georgia, and his master's and PhD in entomology at Auburn. The second talk will feature the work of Brian Curran, who's doing a graduate degree in sweet corn IPM with Dr. Tom Kuhar. And he is at Virginia Tech, and he received his bachelor's in biology from Radford University. So our second speaker will be Dr. Tom Kuhar, who is a professor in the Department of Entomology at Virginia Tech, where his research focuses on IPM of pests of vegetables, including sweet corn. He's a native of Baltimore and received his bachelor's degree in biology from Towson University, with his master's and PhD degrees in entomology from Virginia Tech University. So while we go ahead and get John's slides up, we do have a few questions for you that we would appreciate you answering. So as we finish up answering these questions, these really help us get to know who our audience is, and also your background information. So it looks like about half of you are university extension personnel. We've also got some farmers and processors, and a few regulators or other people who are not involved in sweet corn. And it does look like a slight majority uses insect traps to monitor corn earworms. And some people are not using them because they're not involved in corn earworm management. We also have a decent number who are using these trap captures to guide their spray decisions, and also a few that are not. And about over 50% of people agree or strongly agree that corn earworm moth trap numbers are helpful for improving pest management. Now it looks like we're a little bit less happy, mostly to moderately happy with the corn earworm management in sweet corn at this time. So I think we can go ahead and get started with John's talk.
All right. Well, thank you all again for joining the VRI webinar today. And so today I'm just going to be talking about some work that we have done regarding investigating the optimal trap and lure combinations for monitoring for corn earworm in sweet corn. And so the corn earworm, or Helicobacter is a major pest in sweet corn, as they are able to infest and damage a large proportion of the ears in the crop. And additionally, they are also often difficult to control in the crop as well, as there are issues of insecticide resistance that have also popped up over time. And so the moths from this pest are also able to consistently migrate from the south to the north. And these moths are also often active in sweet corn fields from May through October. And so the female moth of this pest will be attracted to the green silks of the ear of the sweet corn, where she will lay her eggs, and then the larvae will hatch and develop from these eggs, and then make their way to the ear of the corn, where the larvae will feed on the corn kernels, where damage will occur. And so there are a few different tools available that we can utilize to manage for this pest. And one being through the use of BT sweet corn, particularly those varieties that have the FIP3A BT protein in it, as this has been shown to be so really effective in managing for this pest. Whereas all other varieties of sweet corn will have to be sprayed with an insecticide application in order to effectively manage for this pest. And the frequency at which these applications are made can often depend on the abundance of the pest in the fields. And so, one way to measure for the abundance of this pest in the fields can be through the use of a pheromone beta trap. And so, here I have illustrated the use of a Century Heliothis trap baited with the Huracan lure. And so, this lure will be loaded with this chemical pheromone of the one that the female moth will naturally release. And so, once we place this lure at the bottom opening of this trap here, the male moths will be attracted to it and then make their way up to the trap, while they will be captured in this upper portion of the trap. So in addition to the Heliothis trap, there's also the Harsag trap that can also be utilized to monitor for this pest as well. And previous research has shown that this Harsag trap was also able to effectively capture 3 times more moths than that of the Century Heliothis trap. However, we noticed that in this previous research, that the bottom opening of this trap was about 33% larger in the Harsag trap versus the Heliothis trap. And so this may be in part why the Harsag trap may have been performing better than the Heliothis. And then additionally, we also have 4 different lures available used to monitor for this pest as well, including the Huracan, Sentry, Trace A, and Alpha Sense lures. And previous research has also shown that the Huracan lure was able to attract 2 times more moths than the Sentry lure. However, the manufacturing conditions and processing time of these different lure types may have changed since the study that was conducted in 1991. And so with this moth trap capture data, we could then essentially use it against this acid spray threshold guideline table that could provide guidelines on when and how frequently you should spray to manage for this pest. And so if you have an X number of moths captured per night or per week that you're collecting from your traps, you can then use this with the table to look at a guideline on if you should make a spray for this pest based on the number of moths that you have, and if you should spray, how often you should make those spray applications. However, these action threshold guidelines are nearly 30 years old. And so now there is a need to re-examine these guidelines as differences in pheromone trap and lure types can influence the number of moths that are captured. And additionally, information is limited regarding which trap and lure types capture the most moths. And by having a better understanding of this information, it can allow us to more effectively or more accurately monitor for this pest population while making more informed management decisions. And so the overall objective of this study was to identify the optimal trap and pheromone lure for monitoring for cornea moths. And so in the study, we monitored for cornea worm moth populations in Delaware, Maryland, New York, Virginia, and North Carolina in 2022 and 2023. And so here we utilized the Heartstack and Heliostis trap in this study, and we also looked at the use of the green bucket trap as well. And even though the green bucket trap is not utilized to monitor for corneal worm moths, it is utilized to monitor for other moth pests such as the fall armyworm, and is also the cheapest trapping option. So we also wanted to investigate its use as well. And so, as I mentioned with the previous research, that the Heartstack trap was able to capture more moths than the Heliostis trap, but we suspect this may be due to the larger bottom opening in the Heartstack trap versus the Heliostis. So in this study, we modified the Heartstack trap to have the same bottom size opening of the Heliostis trap to more effectively compare the efficacy of these different trap types for capturing corneal worm moths. So here we also use the 4 available lure types, including the Hercon, Sentry, Trace A, and Alpha Sense lures. And then with these different trap and lures in this experiment, we looked at all pairwise combinations to have a total of 12 different treatments. And so with these 12 different trap treatments, we placed them out along the edge of a sweet corn fields, where each of these traps were placed about 80 feet apart from one another. And these traps were then re-randomized once a week in order to minimize any potential local landscape effects that were occurring. And we also counted the number of moths in these traps once every 1 to 4 days. And so looking at our results, where here on the y-axis, we had the mean percent total of moths captured per night. And this will be the same y-axis for the following few bar graphs. And on the x-axis, we have our 3 different trap types. And so here, we did find that the Heartstack trap did capture significantly more moths than the Heliostis trap, as well as the bucket trap. And this was interesting to find because even though we modified the Heartstack and Heliostis trap to have that same bottom size opening, we still found that the Heartstack trap was still capturing more moths. And the reason behind this is not too clear just yet, but we have some collaborators in our study that are currently investigating the behavior of these moths and how they are actually captured in these traps so that we can still improve trap efficacy of these different trap types. And this will be especially important for trying to improve the efficacy of the Heliostis trap, as the Heliostis trap is a cheaper option to utilize than the Heartstack trap, and is also easier to handle in the fields and more commonly utilized among extension agents and growers as well. And so looking at our lure results, which are located here on the x-axis, we found here as well that the Hercon lure was able to attract significantly more moths than all the other different lure types. And so the reason behind this may be due to the amount of pheromone that these lures are releasing over time in the fields. And so to further connect this, if you look at this figure, which is from some ongoing research in our team, where here on the y-axis, we have the quantity of pheromone released in a 24-hour period, and on the x-axis is the lure age in weeks. You can see that with this red line, which represents the Hercon lure, that the Hercon lure is emitting more of this chemical pheromone out in the field the first few weeks than all the other different lure types, showing that this may be the reason why the Hercon lure is performing better and attracting more moths than the other lure types. And so with our trap by lure results in the study, while we did not find a significant effect of a trap by lure combination on the number of moths captured in the study, we did find that, numerically speaking, that the Heartstack trap baited with the Hercon lure was able to capture more moths than all the other different trap by lure types. And so, in summary, we found that the Heartstack trap caught more moths than the Sentry Heliostis trap, despite having the similar bottom opening, and that the Hercon lure attracted more moths than all of the other lures, and that additionally the modified Heartstack trap with the Hercon lure was the best combination for capturing cornea worm moths in the fields. Now, this isn't to say that other trap by lure types can't be utilized, but once we make further modifications to the Ashton threshold guidelines, it may be that we incorporate some type of weighting factor to account for different traps and lures that are utilized, so that those who are using different traps and lures can still be able to make more informed decisions on when and how frequently they should spray for this pest. And so, additionally, just to look at some future research branching off of this current study, one of our collaborators, Christoph, he and potentially some others would also like to investigate the placement of the lure in these traps to better understand how this lure placement could be also impacting the number of moths that are captured in these traps. So, for example, if we were to potentially put the lure just a little below the bottom opening of the trap, or flush with the bottom opening of the trap, or just a little inside the opening of the trap, and compare those different lure placements across trap types to see how that may affect trap capture. And then additionally, Christoph is also currently using this UV camera here to monitor for the moth's flight into these traps at night to also better understand how these moths are actually being captured in these traps as well, with the goal of trying to improve the efficacy of these traps to capture for cornea worm moths. And then lastly, for future additional research efforts, we also plan to investigate the placement of these traps along the sweet corn field as well to see how this could also impact moth trap capture. So here in some preliminary experiments in Geneva, New York, we placed a hardstack and century Heliothis trap baited with the Hercon lure on the west side as well as on the east side of the fields to see which side of the field we may capture more moths on. In our preliminary results, we did find that we were able to capture more moths on the west side of the fields versus the east side of the fields. However, we do plan to continue these experiments and also look at this at a broader geographic scale to see if these trends hold up, and to also see if we can better understand why we may be able to capture more moths on the west side of the field versus the east side. And so with that, I would like to thank all of our collaborators, as well as the NALT Lab for their assistance in the project, and the USDA for funding the project as well. And so with that, we'll pop up some questions for you all to answer.
I'll give you one more minute to finish answering the questions. Looks like a lot of you are paying attention, and it's true that the trap that captured more moss was the heartstack trap. It also looks like in deciding what is most important for monitoring trap, reliability is really the thing that everybody's looking for in terms of getting good quality trap results. All right, Tom, I think you can take it away.
Okay, well, good afternoon, everybody, and great job, John, talking about the pest at hand in sweet corn and what we've learned about trapping the adult stage, the moth stage of that insect. And now it's a perfect segue into, why you might want to use something like traps and what you could possibly get out of it in your production systems. So I'm going to talk about some work that has actually spanned two different graduate students. One got a non-thesis master's, John Few, and then currently Brian Curran is also contributing to this and doing some additional research as well. So John did a great job of explaining the different trap types, and we do have other, some variations in lures, at least 4 commercial lure types, and there's even blacklight traps, which weren't mentioned, but all of these are currently used across the country to monitor for corn earworm. And so now it's, why would you be using traps to monitor for it in the first place? What can you do with your production system? And fortunately, and John brought this up in his talk as well, there have been guidelines or thresholds, if you will, on how to use that moth catch and adjust your spray regimes. And even just so basically it's how can you use the fact that moths are flying and flying at what density in your field to maybe make a decision on how to manage your sweet corn crop for these pests. And that can be difficult with sweet corn because you could be spraying every 2 days. I don't know of another crop that can be more intense than trying to spray sweet corn during the whole silking stage and try to keep corn earworms out of it. So anything that you can do to help with that could be very beneficial. So there are guidelines like this one right here put out by the Northeast IPM Center, and it kind of gives you nice guidelines to manage not only corn earworm but the other pests. So what you'll find in there, and John showed this as well in his talk, is this one that we've kind of using, which is based on the moth catch, either per night, which is basically what you should use, because if you're doing it weekly, you may miss your windows. So there's your number of moths caught, and then that kind of gives you an idea of how often you should, or how much time should you have between your sprays. And it's a threshold that has been used for a while now. It's been up to 3 decades. But I can tell you, I'm in Virginia, and I have known about this since I started my job back in 2001. And the words that I get when I mention this threshold and moth trapping is that, well, that might work for up in the north, but it's not going to work in Virginia. We pretty much need to spray every day, or we're going to have worms in our ears, or every 2 days. So, I probably went with that. I said, well, if that's the way to go, then we'll see what we can do about your wood insecticides you're using and how to come up with good rotations. But it always did bother me that, well, have we evaluated this? So, basically what we did in Virginia is to see what if we followed this spray regime based on moth capture and compared it with what a grower would normally do. And then what kind of damage did we end up getting? So that's exactly what we did. We did this back in 2017, and we did it again in 2023. This time, Brian Curran, helping to lead this, and Helen Dowdy out on the Eastern Shore. So we ran these experiments both on the Eastern Shore in Painter, Virginia, and in Whitethorn, which is in the New River Valley, Appalachian Mountains. And there's a total of 7 experiments. One of them was just one of those locations. And each of those years and locations, it was a randomized, replicated small plot experiment. So this wasn't just one example. This was, each one of those was an individual experiment, randomized, replicated. And then all the data were combined to help answer this question. Could this potentially work in Virginia? So we had 3 treatments. One was not sprayed at all, untreated check. The second we called IPM, and this was it initiated with a spray of Coragen at tassel push. So the first sites of silks, we did put an application of Coragen. That's a very susceptible time. And after that, we only sprayed if and when the threshold told us that that we should spray, and we rotated to Radiant, or we may have rotated with Warrior, depending on the year that we did it. And then we compared this with what was the conventional sprays that a grower were using. I will say in 2017, there was a lot of pyrethroids. So Warrior 2 was our conventional insecticide, and that was sprayed every 2 to 3 days. Usually resulted in 6 sprays or so. But by 2023, we rotated that to Besiege, which has a pyrethroid in it, but also has the diamide that's in Coragen. And the reason we did that was because of pyrethroid resistance starting to show up in some of our population. So basically that's the comparison, 3 treatments. And all of them, the first spray was initiated approximately 10% of the ears had silks. So at harvest, so after all sprays were done and the corn was ripe and ready, we picked 50 ears from each plot and evaluated them for damage and whether they had a worm in there. We actually rated several variables, but I'm going to show you the one that is probably the best variable, and that is percent clean ears, because this is what the growers are going to need when they're marketing their sweet corn. So this is a kind of a complicated table, but I will say you've got the year and locations of each of the trials listed on the rows. And that average corn earworm moth catch, that's basically to give you an idea of what kind of moth flight pressure we were getting at each of those locations. And, Painter in 2018 clearly had the most pest pressure, 138 moths caught in a week. And the next two columns, threshold and standard, these are the number of insecticide sprays that were applied in that trial. And you can see usually it was less in the threshold compared to the standard, which was every 2 to 3 days. And then the last three columns were the percentage of clean ears that were harvested from these three different treatments. And if you just go right down to the bottom, you see the average, and basically there was absolutely no difference between following the threshold and spraying every 2 to 3 days. And the last column would indicate, yes, you pretty much did need to spray some, or you were not going to get many ears free of worms. So yeah, there's just another way of looking at that same data, percent clean ears, but it does highlight the differences in the number of sprays. So following the moth trap catch data, you ended up with about 2 to 5 sprays versus 6 to 7 if you were spraying every 2 to 3 days, which is what growers typically do in Virginia. So, I'll just leave you with that. How much is spraying 1 or 2 times less during a crop? What is that worth to you? And it's, it could be a lot of things. It could be money. It could be a day that you went fishing instead of spraying your sweet corn. So in the middle of August. So, that alone is value to a grower if you can cut out a spray. I will say these are scientific data, but I have anecdotal data from a couple growers who have said that using the moth trap has saved them at least a spray when they plant their sweet corn. So this is this work that I just presented is summarized, and it's on the website that Kelly mentioned at cornearwormipm.org. And it basically shows the same exact stuff if you wanted it as kind of a handout. And you can download this, from that website under resources. So that's all number of sprays and a little bit of economics, and it shows that it can work. But there's other things when you follow an IPM approach. That is that you may be conserving things by not spraying as often, by not spraying possibly at all. And there's a lot of things that come to sweet corn, in particularly when that corn is producing pollen and pollen shed. You will see there's a lot of natural enemies, I will say, but the ones that I see the most are our lady beetles. And then we have this little tiny bug called the minute pirate bug. And those two seem to be the most predominant arthropods that are out there. They're very beneficial. They eat aphids. They eat the eggs and larvae of corn earworms, especially that neonate hatchling that comes out of the egg. And before it crawls down into the ear, it's possible that if a little Aureus bug finds it, it will eat it. And that will never be a worm that ended up in the ear. And then we also get bees, honeybees, and other pollinators that will come and gather pollen. Corn is not an insect pollinated crop, but when it produces pollen, the insects come and they feed on it. That's for sure. So avoiding a spray, could potentially keep these things in the system, and they are extremely valuable. So, and there's a lot of papers. This is one review article that just basically shows, when you spray insecticides, based on what you spray, when you spray it. can really have a devastating effect on these natural enemies. It just seems very logical that that does occur. You spray something that kills natural enemies. Hey, guess what? You affected natural enemies. So that's if you can avoid it, then the better for your whole system. So now that kind of gets into what you spray and how this fits into IPM. We already know that if you follow a threshold, you can maybe reduce sprays. But if you used insecticides that had less impact, that would also contribute. So things like Coragen and Vantacor that are circled in blue are diamides that do not harm any of those natural enemies or the pollinators. The spinosins circled in green, like Blackhawk, Radiant, and Trust, these are pretty safe to the predators, so that minute pirate bug would do just fine with a spinosad spray. They are a little bit harmful on parasitic wasps and a little bit on the pollinators, but a lot less than if you had sprayed a pyrethroid, which is the tool of choice, or something like Lanate, which is pretty harsh on them as well, a carbamate. So there is differences in the insecticides. One thing that I'd like to recommend, that if you're going to use an insecticide, or if you're going to use Coragen or Vantacor, which are the diamides, that use it during that pollination stage, because that is when most of the bees and most of the natural enemies are going to be at their highest abundance in sweet corn. So you might as well not kill them if you can, and you can avoid it by choosing one of those insecticides. And this, I won't show all the data. Brian Curran, the grad student, is still crunching some of these numbers, but it does illustrate. So this is in 2023. This is numbers of lady beetles that were counted on the plants. And pollination was going on during that first application there. And you see that if you use the Coragen, or you didn't spray at all, you had high numbers of lady beetles. You sprayed the pyrethroid and there were none. You basically killed them all. So that clearly shows that. We can show that with a lot of natural enemies, but you also see that when it stops pollinating, when the corn stops pollinating, and in this case, it was a few days later, that those natural enemies start to drop off in the field naturally. They just leave. The pollen's not there. So their time at their most at risk is when the corn is pollinating. So after all that being said, all this IPM talk, conserving natural enemies, I will say that I'm not preaching to get rid of all pyrethroid sprays if you're a sweet corn grower, or at least a conventional sweet corn grower. If you're organic, yes, you shouldn't be using pyrethroids at all. But and that is because there are some other insects that maybe that one pyrethroid spray could really help knock back things like stink bugs, because the only thing that's going to kill them, on that list is going to be the pyrethroid. And then things like sap beetles that may not be controlled very well by a spray of Coragen, but the pyrethroid would help keep them back. So we're talking about rotations of insecticides, and maybe a pyrethroid fit in there, maybe a little bit later in the spray rotation might not be a bad idea, depending on what you're seeing. So that's all I have for this talk. I definitely want to, there's no way we can do all this work. If you do any sweet corn research, you know that it takes people. You're hand harvesting, you're evaluating ears, and I've had a great group. I want to thank them all. And especially Helen Dowdy on the Eastern Shore, who basically ran these same studies out there, and I was more in the Whitethorn area, near Virginia Tech's campus. So I think we have a couple questions, and then I think we will go to a Q&A panel after we answer a couple questions.
Yes, everyone, please take a few moments to answer a couple questions, and then we will have a little bit of wrap up, and then some question and answer session. So it looks like quite a few of you are altering whether your spray timing or what choice of insecticide you're using, based on whether you're seeing beneficial insects like bees or lady beetles. and we're paying attention, that the Coragen or Vantacor is one of the ones that's least toxic to bees. So as we wrap up here, I just wanted to point out, we have an economist that's working as part of our project. And one of the things that we really want to do is get good estimates for the value, for how much it costs to manage corn earworm and be able to compare different programs. And of course, as we mentioned, some of these insecticides that are more softer on beneficials may be more expensive. And so really trying to pencil out when that is worth it or not, and in which situations it's worth it. So to help us do that, if you are growing fresh market sweet corn or you have contacts with fresh market sweet corn growers, we would really appreciate if you could send them to our economic survey and get them to fill that out. And I will paste a link to the survey as well in the chat. We would also really like to thank the federal funding that we've received for this project, and federal funding is also essential for funding the Northeast IPM Center. So this work was funded by a Specialty Crop Research Initiative grant from the United States Department of Agriculture, National Agriculture and Food Research Initiative. So we really appreciate that funding. And we have some final post webinar questions for you, which we would like you to go ahead and start working on. But so while we get ready for the Q&A. So please, again, any questions that you have for our panelists, start putting them in the chat, and we will start organizing and prioritizing questions to answer live or typing in answers to the questions. So one of the first questions that I think I'm going to have you address, Tom, for the group is and I'm going to combine a couple of them, which is really related to what can we do to protect natural enemies? Is Ryman an option? Does spraying after sunset affect which insects are impacted?
Yeah, those are great questions. We'll start with the Ryman. Ryman is an insect growth regulator. It is one that, I saw when it first came out. We evaluated it in various vegetable crops, and it does work. It does work well on Lepidopteran larvae, including corn earworm, on crops like tomato, when, it's kind of sprayed on a plant, they're exposed, and they're feeding. We've found that it has not worked as well to protect the ear in sweet corn because, what you have there is a egg that hatches and that little larvae crawls down the silk, and it's possible that they don't ingest that insect growth regulator to actually kill it. So it's been difficult to get as effective results in sweet corn as we have in other crops with Ryman. So we're not feeling as confident about that as some of the insecticides that were presented. That's the Ryman one. There was something about natural enemies. I've already forgotten.
So for protecting natural enemies, and does spraying after sunset help?
Well, it definitely helps the bees. For the bees, I think that's a good option. And yeah, so the residue will dry. I think as a whole, that's probably not a bad way to go because of the bees are in the mixture. I'm not so sure about the other predators. I think they stay in the tassels and the silks, whether it's daytime or nighttime. So, but it would definitely help out with the pollinators.
John, we have a few for you related to whether it matters to like at what point do you want the pheromone lure strength to be higher? Does that equal, like, is catching more moths gonna plateau at some point? And why? Do you have a sense of why these pheromones vary in terms of how strong they are in releasing pheromone? And I'm happy to chime in too if you need.
Yeah, I think I was just reading that. That's like the two-part question, is there a point where more pheromone strength in a lure doesn't equal more moths captured? So for that first portion of the question, I don't, yeah, I don't fully understand that. Christoph might have a better idea on that, or maybe some others on the team, but yeah, I'm not sure about that part of the question. But in regard to the second part, where it says, is the strength mostly limited by the manufacturing cost? Um, well, I will say that at least with the 4 different lure types that I presented today, that the Huracan lure is the only one that's in this flat PVC strip, um, which, after talking to Christoph, the chemical ecologist on the team, it may be that one's, releasing more of the pheromone because it's in that dispenser type where it has this greater surface area, allowing more of the pheromone to be released, whereas the other ones are in this rubber septa. But yeah, I don't know if Kelly or others have anything to add to that first part of the question at the least, in terms of like, is there like a threshold where if these lures are releasing more pheromone, does it just cap off at some point where you're not going to see more moths being attracted to it?
I think that sometimes too, the how many moths you can hold in the top of the trap ends up, you reach a level where you've caught as many as you can. And in general with insect trapping, it's not so much that you need to capture more as that you want to be sensitive. So you want to be making sure that you're capturing moths when there's not, you really want to be sure that your zeros are zeros, so to speak. And that can matter even more than catching the most moths. So that's definitely stuff, things that we're looking at and confirming with our trapping and why we're interested in those questions about where we place the traps and things like that. So it looks like another few questions that we've had, maybe toss back to Tom on in terms of what are the best insecticides to be using on a smaller scale if you don't want to be tank mixing. And then I also think if you would mention the resistance to diamide question answer for the group as well.
So I guess the question was, if you're a small sweet corn grower, what insecticides is that? So we're talking about, where you have to buy them in smaller quantities. I'm not sure if I heard that question properly with regard to the word small. Was it like a
Smaller
small?
acreage, so a couple, I think it was a couple acres. And they just want recommendations where they don't have to tank mix 2 to 3 different chemicals for controlling corn earworm.
Yeah, gotcha. Well, one thing, the Coragen Evo, which is the new product now, comes out in a smaller bottle. It used to be you had to get a 1 gallon or 2.5 gallon jug of that, which was a lot of insecticide for smaller growers and very, very expensive. They make the Coragen Evo now, quart size at least. It might be even smaller. And that's probably one that would be very, very handy. It's safer on the natural enemies, and now you can get it in a smaller quantity. And it's also very possible, given where you're living, if you're more into the Northeast, that you don't need a lot of other options. Maybe having a pyrethroid on hand in case you get other things, or it's a really, really heavy year, and then you could rotate to that. And I also think having like one of the spinosins, depending on what kind of grower, you can get Blackhawk or you can get Radiant. As it, those are good insecticides, and a lot of these companies are making them available in smaller quantities now. But I think definitely the Coragen Evo is a good one that I would have. Oh, you wanted me to talk about the diamide resistance?
Yes, could you mention
Yeah.
that just for everyone? So there was a question about whether or not there's any evidence that diamides might be having issues with resistance.
Yeah, it's something that I think we're right on the verge of hearing more about. It's a concern, for sure. The one thing we do know, the biggest issues are with pyrethroids and then probably some lannate resistance in there. that's more prevalent in corn earworm populations. The other thing, just thinking about resistance as a whole, that, it's not once you hear about it one place that, that's it, we can't use that. I mean, it can be very localized, even for an insect like corn earworm that we know moves. We have seen where you have resistance one year, and then for some reason the next year, corn earworm, that insecticide seems to be working pretty well. And then, so there's a lot that we're still trying to learn, and this working group that we have is trying to address some of those questions. But back to the diamides, I think of all the insecticides right now, it's not shown up in high levels. It's a concern, and we may have had some documentation, but it's not something that is completely widespread. But something we need to be keeping an eye on for sure.
So we have a question regarding potential hybridization between corn earworm and I believe it's the old world bollworm, so Zea and Armigera, and how that might be impacting management and whether our recommendations need to be updated with that situation as it's emerging.
Yeah, so far I think it's an issue out west, Colorado, and but definitely, as time goes on, we will see the populations mixing, and maybe some of the western moths making their way further to the east. But so far, that issue where this old world corn earworm has hybridized with our current corn earworm, and the problem there is that it's bringing more resistance issues. That's not something we're facing on the East Coast, but we're aware of what's going on out there, and I think over time we'll see whether that makes its way, to this part of the country.
Yes, I will just follow up on that. That there are a few groups of insecticides that Armigera is more resistant to than Zea, so our corn earworm. But our corn earworm is pretty resistant to a lot of the same things. And currently in terms of management and the fact that they might be sharing genetics, that may be some of the reason why we're seeing increased problems, but that resistance was also developing. So again, as Tom mentioned, we want to be managing for resistance before we see it, rotating insecticides as much as possible. All of these things are helping. Let me see terms of, okay, so we have a question regarding Coragen. Does it offer European corn borer control?
Which I'm sorry, Kelly, I was typing an answer to another question.
Sorry.
I should
There
be
was a
looking.
question related to whether Coragen offers European corn borer control.
Yes, it does.
And I also am going to go ahead. We answered one question in writing, but I would like to bring up, someone mentioned releasing trichogramma wasps as a biological control option for corn earworm. And certainly it's not compatible if you're spraying conventional insecticides. It may work a little bit better if you're using softer insecticides, but really the trichogramma are really good for European corn borer and they're not as good for corn earworm. So we don't necessarily recommend releasing them. And we're also not sure that would economically pay off. In studies that have been done where they've really released quite a lot of wasps, they didn't really see enough control to yield marketable ears there.
Yeah, and I think if you're in an area that has a lot of corn borer, and corn borer is still your dominant pest of corn ears, that's probably further north, that trichogramma probably are a better option for those growers than they may be for, especially me down here in Virginia. We just get pretty high levels of corn earworm.
So we're right on the hour. The panelists have all agreed to stay on if there's more question and answer. But we thank you all for your attention, and thank you the Northeast IPM Center for hosting this webinar. And again, please follow our project updates or feel free to reach out at cewipm.org. So while people are deciding whether they want to stick around, I think you started answering a question related to GMO acceptance and how much Remedy and Milky Way are getting traction with consumers. If you want to have a discussion on that, Tom.
I mean, I don't know if I can. I'm very interested in what we found out. I know Penn State did a study, but this was not the Milky Way and the Remedy. This was the other, the Cry 1A BT sweet corn. But they did research on it and got feedback from grower acceptance. But again, that's over a decade old now. And I would really, really love to know if there are just how much aversion there is to GMO crops, or is there just something with the fact that it's the varieties that we have for Remedy and Milky Way, and that just doesn't fit for what the growers want. Be nice to know what the reasons are.
Yeah, I think that a lot of us have been asking those questions and we really don't have a good answer for it. Because I also think there's a lot of concern whether there is consumer acceptance. So the fact that that's an unknown is enough to make people unwilling to grow some of these BT corns. It would be my take on that question. There are more and more varieties available that have the effective VIP. And so in terms of the different bicolor or white or pure yellow, there's more of that. And I think that there's the flavors there, in my opinion. But yeah, we don't know the answer to consumer acceptance and how much market penetration that has.
Hey, Kelly, I'll probably also add to that question too that some sweet corn growers too, there's going to be a portion of them that are going to be for processing as well. And so those processors aren't going to grow those BT varieties as like some of these other countries that can receive that sweet corn will not accept BT.
All right, if there's any last minute questions, please drop them in the chat. Seeing any more questions? Thank everyone for showing up. Have a good rest of your afternoon.